Stop.
Today we are going to perform the experiment on LCR meter. By using LCR meter we can measure the resistance, inductance, capacitance for the given DUT. Here DUT stands for device under test. In this LCR meter will give the AC supply to the DUT. Then it will take the V by current will AC current will be passing through this DUT, so that it will get the impedance that is equal to V by I ratio. Impedance having magnitude and angle in polar form. If we write in a rectangular form, it will be Z cos theta plus J into Z sin theta. This Z cos theta will be the resistance, and if the angle is positive, Z sin theta will be positive, so it will give the inductive reactance. If angle is negative, impedance angle is negative, then it will give the minus Z sin theta, means it will give the capacitive reactance. If the theta is 0 degrees, then circuit is purely resistive, and that resistance we can find by using this expression R is equal to Z into cos theta. When theta is equals to 0, then it is equal to magnitude of impedance. When theta is positive, then circuit or DUT will have R and L components. R can be determined by using Z cos theta, and L can be determined by using Z sin theta divided by 2 pi f, where f is the frequency, supply frequency. When theta is negative, circuit or DUT will have R and C elements. R can be determined by using Z cos theta, and C can be determined by using 1 by Z sin theta into 2 pi f. Unit for capacitance is farad, and from R and C values we can find the dissipation factor, that is equal to omega RC, where omega is 2 pi into f. We have connected this LCR meter across the rheostat, means here rheostat is the DUT. For this rheostat we are going to measure the resistance and inductance with different values of frequencies. Now I set resistance here, R symbol is showing, and I am going to set the frequency as 100 Hz. For 100 Hz, resistance of rheostat is 170.18 ohm. For 120 Hz, resistance is 170.41 ohms. For 1 kHz, resistance is 178.96 ohms. For 10 kHz, resistance is 223.5 ohms. For 100 kHz, resistance is 414.7 ohms for the DUT. Now I am going to measure the inductance. By clicking on this ZLCR option, we can get the inductance. Now we have got inductance. Now I am going to set the frequency as 100 Hz. For 100 Hz frequency, inductance for the given rheostat is 6.1 millihenry. For 120 Hz, inductance is 5.83 millihenry. For 1 kHz, inductance is 2.98 millihenry. For 10 kHz, inductance is 1241.7 microhenry. For 100 kHz, inductance for the given rheostat is 397.3 microhenry. Now I am going to remove the rheostat. Now we have connected 2 microfarad 500 volts AC capacitor across the LCR meter, and first we are going to choose the resistance. For that I am clicking on ZLCR. We have chosen a resistance, and frequency I am going to set it as 100 Hz. For 100 Hz frequency, the resistance is varying and it is giving 0.06 ohms. For 120 Hz it is 0.08 ohms. For 1 kHz it is giving 0.35 ohms. For 10 kHz it is 0.147 ohms. For 100 kHz the resistance is 0.096 ohms. Now I am going to set the frequency is 100 Hz and capacitance I am going to set here. Now I am going to measure the capacitance for the given capacitor. For 100 Hz the capacitance is 2.017 microfarad. For 120 Hz the capacitance is 2.017 microfarad. If we observe the dissipation factor for 100 Hz and 120 Hz, it is showing 0.00. It is not exactly 0 because we have some resistance also, small resistance. So omega RC will be not equal to exactly 0, it will be nearly 0. For 1 kHz the dissipation factor is 0.004 and capacitance value is 2.016 microfarad. For 10 kHz dissipation factor is 0.047 and capacitance value is 2.025 microfarad. For 100 kHz the dissipation factor is 0.751 and capacitance value is 3.10 microfarad. We have measured the resistance, capacitance and dissipation factor for the given capacitor. Now I am removing this capacitor and I am going to measure the inductance, resistance for the given transformer windings. Now we can see the single phase transformer. This transformer having two windings, one is low voltage winding and here high voltage winding. Between these two terminals, high voltage winding, between these two terminals we have low voltage winding. Now we have connected the LCR meter across the LV winding terminals. For this transformer, first I am going to measure the resistance. I set the resistance for 100 Hz. For 100 Hz it is giving 7.6 ohms. For 120 Hz resistance is 9.78 ohms. For 1 kHz resistance is 233.2 ohms. For 10 kHz resistance for the given LV winding is 2.802 kilo ohm. For 100 kHz, resistance is 71.99 ohms. Now I am going to measure the inductance for the LV winding. For that I am clicking on ZLCR and I am choosing the L option, and now I am going to set the frequency as 100 Hz. For 100 Hz frequency, inductance across the LV winding is 138.07 millihenry. For 120 Hz, the inductance across the LV winding is 136.94 millihenry. For 1 kHz, the inductance is 104.44 millihenry. For 10 kHz, the inductance across the LV winding is 9.65 millihenry. For 100 kHz, the value of inductance is giving negative, and if we observe the impedance angle, it is minus 79.3 degree. We know if the impedance angle is negative, then we can say that the DUT is having resistance and capacitive behavior. So we have to choose the capacitance at 100 kHz. This LV winding will be acted as resistance and capacitance. So at 100 kHz, capacitance across the LV winding is 4.155 nanofarad and dissipation factor is 0.19. Now I am going to measure the resistance inductance for the high voltage winding. Now we have connected the LCR meter across the high voltage winding terminals of transformer. Now I am choosing the resistance across the high voltage winding terminals and frequency I set 100 Hz. For 100 Hz frequency, resistance across the high voltage winding terminal is 32.01 ohm. For 120 Hz, resistance across the high voltage winding is 39.64 ohms. For 1 kHz, the resistance across the high voltage winding is 932 ohm. For 10 kHz, the resistance across the high voltage winding is 11.258 kilo ohm. For 100 kHz, the resistance across the high voltage winding is 204.4 ohm. Now I am setting the frequency as 100 Hz and I am choosing the inductance. For 100 Hz, the inductance across the high voltage winding terminals is 552.5 millihenry. For 120 Hz, the inductance across the high voltage winding terminals is 542 millihenry. For 1 kHz, the inductance across the high voltage winding is 412.8 millihenry. For 10 kHz, the inductance across the high voltage winding terminals is 38.79 millihenry. For 100 kHz, here the inductance value is showing negative, and if we observe the impedance angle, it is minus 84.3 degrees. It means at 100 kHz frequency, the high voltage winding will act as resistance and capacitive behavior. So we have to choose the capacitance at 100 kHz. At 100 kHz, the capacitance across the high voltage winding terminals is 772.4 picofarad, and we can see the dissipation factor is 0.097. With this, we have measured the resistance, inductance, capacitance values for the given single phase transformer. Thank you.